Welcome back to Introduction to Symbolic Logic. This is lecture 11. Our topic today is multiple generality. Multiple generality means sentences that combine multiple quantifiers into one sentence. And so we are going to talk about different topics having to do with multiple generality. We are first going to discuss how to symbolize quantified sentences in English. And we are going to proceed in two steps. We are first going to discuss how to symbolize quantified sentences in general in English, and then specifically talk about sentences that use multiple quantifiers, since that case creates special challenges. And then we are going to discuss the substitution method for assessing quantified sentences with a special eye on multiple generality and with a special eye on how to assess the truth of sentences that use more than one quantifier. And then we are going to look at two important applications of multiple generality, namely to counting sentences and to definite descriptions. Okay, let's talk about symbolizing quantified sentences in FOL. Most English sentences that you are going to be asked to symbolize in this class have one of the following four forms. They could be of the form all F's are G, or some F is G, or no F is G, or only F's are G. Now, whenever an English sentence is of the form all F's are G, you can symbolize the sentence by means of the following FOL symbolization. For all X, if X is F, then X is G. Furthermore, whenever an English sentence is of the form some F is G, you can symbolize this sentence by means of the FOL sentence there is an X such that Fx and Gx. Now, whenever an English sentence is of the form no F is G, you have a choice. You can either symbolize the sentence by means of a negated existential quantifier and say that it is not the case that there is an X such that Fx and Gx, or you can symbolize the sentence by means of a universal quantifier and say that for all X, if X is F, then X is not G. Finally, for English sentences of the form only F's are G, you again have a choice. You can either symbolize these sentences by means of a negated existential quantifier and say that it is not the case that there is an X such that Gx and not Fx. Or you can say that for all X, if X is G, then X is F. So here you may have noticed that only F's are G. The English sentence only F's are G can be symbolized in exactly the same way as the English sentence all F's are G. So let's look at a few examples. Suppose you want to symbolize this sentence here. Every coin in my pocket is a quarter. And I just made up a symbolization key. So here I'm symbolizing the predicate is a coin by means of the capital letter C, and the predicate is in my pocket by means of the predicate P, and the capital letter P, and the predicate is a quarter by means of the capital letter Q. Now, given this symbolization key, I can symbolize the sentence every coin in my pocket is a quarter by means of the universally quantified sentence for all X, if Cx and Px, then Qx. Now, let's look at a second example. Suppose you want to symbolize the English sentence some coin on the table is a dime. And as before, I symbolize coin by means of C, and I symbolize on the table by means of T, and I symbolize dime by means of D. I can then symbolize this whole sentence as follows. There is an X such that Cx and tx and dx. To look at a third example, suppose you want to symbolize the sentence, no coin on the table is a dime. You can symbolize this sentence by simply prefixing the sentence we just looked at with the negation sign. So you can say that it is not the case that there is a coin you can say that it's not the case that there is an x such that cx and tx and dx. Now, finally, to symbolize the sentence, only dimes are on the table, you can do that as follows. You can symbolize it by means of the negated existential quantifier here. It is not the case that there is an x such that tx and not dx. Okay, these were really simple examples. Often we want to symbolize more complicated sentences. And in those cases, it is helpful to have a strategy. So I want to suggest to you a 5-step strategy. Whenever you want to symbolize a more complicated English sentence, it helps to proceed as follows. Start with a paraphrase that makes the underlying formal structure of the sentence you want to symbolize transparent. Then identify this underlying formal structure. Provide a symbolization key for all the relevant predicates. Symbolize the components of your sentence. And then put it all together. Take the formal structure that you have identified and the components that you have already symbolized and create a symbolization of your sentence. So here's an example. Suppose you want to symbolize the sentence, there are reptiles which are not alligators. According to the strategy that I'm suggesting to you, we should start with a paraphrase. And what I'm suggesting here is we can say that some reptiles are not alligators. And here I've just replaced there are reptiles which with the two words some reptiles, and so on and so forth. And why did I do that? Well, this paraphrase really makes the underlying formal structure transparent. Our sentence has the form some F's are not G. And that is very close to one of the general forms that we have seen in the beginning of this lecture. Next, we need to provide a symbolization key for our predicates. And I will suggest to symbolize the predicate X is a reptile by means of the capital letter R. And I will symbolize X as an alligator by means of the capital letter A. And now we can symbolize our components. So we said that our sentence has the general form some F's are not G. And we are also, and here the predicate F abbreviates reptiles and G abbreviates alligators. And so if we symbolize our components F and G, that gives us as an intermediate result the sentence that some X's, which are not A. Some Rx is not AX. So this is not our final sentence, this is just an intermediate step where I've taken the general formal structure of our sentence and symbolized the two components F and G. And then in the final step, we put it all together. I know that I can symbolize sentences of the form some F's are G by means of the formal sentence there is an X such that Fx and Gx. And so I can symbolize our sentence some reptiles are not alligators by means of the quantified sentence there is an X such that Rx and not Ax. And that's it. So here we are done. That was our example for how you can symbolize more complex English sentences in FOL. Now let's talk about a few caveats and complications. If you do not specify a domain, we will in general assume that the domain includes absolutely everything whatsoever. In some cases, you can, however, make your job easier by specifying a domain. So, for example, we just looked at the sentence, there are reptiles which are not alligators. And we symbolized this sentence like this. We said there is an X such that Rx and not Ax. Now, alternatively, we could also have stipulated that our domain includes all and only reptiles. If we did that, we could symbolize sentence 1, there are reptiles which are not alligators, more simply as there is an X such that not Ax. Since our domain, according to our stipulation, includes only reptiles, that means that there is a reptile which is not an alligator. Okay, that was the first caveat. Second caveat, it is often very important to pay attention to the scope of quantifiers. So what do we mean by the scope of a quantifier? In our first line here, the quantifier has narrow scope. So the scope of the quantifier only includes the antecedent of the conditional. The consequent FA is not in the scope of the quantifier. So the quantifier has narrow scope. In our other formal sentence here, a little further down the road, the quantifier has wide scope. So here the quantifier includes the entire conditional within its scope, and that means that it has wide scope. Now, these two sentences are crucially different, or mean crucially different things. So suppose the predicate F stands for is brilliant. If we understand F in this way, then the narrow scope sentence can be understood as saying if everyone is brilliant, then Anna is brilliant. But the wide scope sentence can be understood as saying everyone is such that if he or she is brilliant, then Anna is brilliant. And those are two crucially different sentences. So it's always important to pay attention to the scope of the quantifier and in particular to whether the quantifier has wide or narrow scope. Now, a final important caveat, sometimes we need to disambiguate similar sounding predicates when we symbolize a sentence. So for example, think about this argument here. Carol is a skilled surgeon and a tennis player. Therefore, Carol is a skilled tennis player. Now, this clearly doesn't follow. Just because Carol is skilled as a surgeon doesn't mean that Carol is skilled as a tennis player. So to explain why this argument is invalid, we would need to symbolize the two words skilled in the premise and in the conclusion by means of different predicates and disambiguate, even though in English they sound similar. Okay, we have seen how we can symbolize English sentences in FOL. We are next going to move on and think about multiple generality and about how we can symbolize sentences that use multiple quantifiers in FOL.